The second part of the chapter is the velocity time graph. Okay. So what will be velocity time graph, children? Graph plotted with velocity along the y-axis and time along the x-axis. In mechanics, always the time will be represented on x-axis. So we will see how the velocity is changing with respect to time. So some data is given. So if it is increasing velocity, see in 0 second, 0, 5 second, 2.5, 10 second, 5. So that means it is increasing at a constant rate. And in the second one, it is decreasing. So how we will draw the graph is, suppose if the velocity is not changing, that means constant velocity means it is same like position time graph when the body is at rest. Suppose if the velocity is 20, it will remain at 20 itself. So what will be the shape of the graph? For constant velocity, it will be a straight line parallel to x-axis. And what will be the slope? There is no slope. Slope will be 0. What is slope? The angle which the graph makes with x-axis. What is the angle which the graph makes with x-axis? Is 0. Now, when the velocity is increasing continuously, that means constantly increasing with equal velocity change. See, 2.5, 5, 7.5, 10. It is increasing the velocity at 2.5. So that is called a constant acceleration. And if it is decreasing constantly, then it is called constant acceleration. But this acceleration is called negative acceleration as it is decreasing, and that is called a retardation. So what will be the shape of the graph if it is constant acceleration? Straight line with a positive slope. And if it is retardation, straight line with a negative slope. So what will be the slope here? You know how to find the slope, right? Slope is equal to opposite side by adjacent side. So we will take any. Okay, for example, if you are taking this, how we will find the slope is, what is theta? Opposite side. What is opposite side? 15 minus 0 divided by, what is the time taken for that? 30 minus 0. So you'll get it as 1/2, or it is 0.5. Unit of acceleration is meter per second square. Here also, it is negative. So what will be the slope, children? Slope will be also negative. That means what is the initial velocity is 15 and final velocity will be 0. So 0 minus 15 divided by time is 30 minus 0, because time cannot be negative, 30. So you'll get this minus 0.5 meter per second square. So again, recollecting, slope of distance time graph gives speed. Slope of displacement time graph gives velocity. Slope of velocity time graph will give you acceleration. So these are the things what we get from a velocity time graph. See, calculating the acceleration, it is the same way as we have done the calculation of velocity. So now, what do we get? Other than this, what we get from a velocity time graph is we can find the area inside the graph. Suppose if you are calculating the area for a constant velocity, see what is the area? Area is equal to length into breadth. Length is time and breadth is velocity. So what is velocity into time? Distance traveled, or it will give us the displacement. In this chapter, it is straight line motion. Distance and displacement will be same. Distance will become equal to displacement when they are traveling in same direction. So same way here, if you find the area under the graph, you will get this as rectangle plus triangle. And when you calculate, you will get it as half ut plus half at square, which you will get it as displacement again, which we will be deriving it in our equations of motion. So don't forget that slope of distance time, velocity time graph will give you acceleration, and area under the velocity time graph will give you distance time. So let's see the kinematic equations of motion. Kinematic equations means equation which connects all the terms which are involved in motion. That means the major terms which are involved in motion are initial velocity u, time t, distance traveled S, acceleration A, and final velocity V. So equations are made with these 5 letters, these 5 terms: initial velocity, time, distance traveled, acceleration, and velocity. The first equation is V equal to U plus AT. We will derive that. And what is missing in this is S. Second equation, we will start with S. S is equal to UT plus half AT square. What is missing is V. And third equation is V square is equal to U square plus 2AS. What is missing is T. Okay, you can remember it as my name, Sina V. Neath. Okay, so we have 5 terms, but in every equation, 1 term will be missing. Okay, and who is common in all of them is, here you can find U, here you can find U, here you can find U. Here you can find A, A, A. So what is common in all the 3 equations are U and A. Okay, so we are going to find a relation connecting UTSAV. I write it because it is like Utsav. After this, we will have a festival of problems. So we are going to write the introduction. Whichever derivation they ask, you need to write the derivation introduction. Like consider an object. Okay. Consider an object moving with velocity. Consider an object moving with initial velocity. Moving with initial velocity. What is the initial velocity? Initial velocity U meter per second. Okay. Accelerated at, we are accelerating the particle. So it is accelerated at A meter per second square. For how long? For T seconds. For T seconds. Okay. Attaining a final velocity. Attaining a final velocity. Attaining a final velocity V meter per second, traveling a distance of, how long? Traveling a distance of S meters. So this is the introduction you will write for all the equations of motion. Okay. So what are the terms which are involved in this? U, A, T, V, and S. Okay. So now we will draw the velocity time graph and we will derive all of them one by one. This is the velocity time graph. Time and velocity. Okay. In the introduction, it is said that initially it was having a velocity U. Then it uniformly accelerated for T seconds to attain a final velocity V. So what is the final velocity attained is V. Okay. So I can mark this as, this is the final velocity V and this is the final velocity V. Okay. And we have the initial velocity as U. I'm marking all the points on the graph. This is O, A, okay, B, C, and D. The first equation of motion. What is the first equation of motion is? It is the relation connecting velocity, time relation. Velocity, time relation. In velocity, time relation, okay, we are finding the slope of the graph. So acceleration is given by slope of VT graph. Okay. And what is the slope of VT graph? Here, there is slope only in the region CD. So A is equal to slope of CD. Okay. So I will find the slope opposite side. What is that? BC divided by adjacent side, which is BD. So if this is T, this is also T. And what is this distance? this will be V minus U. So what is BC? V minus U divided by T. So what you will get from this is A is equal to V minus U by T. That is V minus U is equal to AT, or V is equal to U plus AT. This is the first equation of motion. And what is missing in that is S. So we start with the second one with S. What is that? Displacement time correlation. To find displacement, I need the area under the graph. Area under VT graph. Area under VT graph will give us displacement. So I start with S is equal to, what is the area under the graph? Area of this rectangle plus area of triangle. So OABD, area of OABD plus area of the triangle BDC. We all know that area of the rectangle is length into breadth, and area of the triangle is half into base into height. So from the diagram, you will get L into B as U into T plus base of the triangle is T, and height of the triangle, you will get it as BC. What is the height of the triangle BC? B minus U. And we know that V minus U is 80. So when you simplify, you will get S is equal to UT plus half T into 80 is 80 square. So this is the second relation where velocity, final velocity is missing. Moving to the third one. Third one is also the same concept, but it is displacement velocity relation. Time will not come. So you know that area S is equal to area under the VT graph, but I will take the whole area. That is, I will take it as trapezium. I will not divide it into rectangle and triangle. So what is the area of a trapezium name? OACD. OACD. How you will find the area of the trapezium is sum of parallel sides. Trapezium has two parallel sides divided by 2 into the distance between the two parallel sides, which is the height. So in this case, the parallel sides are V and U, and the distance between them is T. So how can I write this? This is equal to V plus U by 2 into time. And we know that V minus U is equal to 80. So what is T? V minus U divided by A. So I can write S is equal to V plus U by 2 into V minus U by A. All my children know that A plus B into A minus B. A plus B into A minus B is A square minus B square. And when 2A goes to the other side, 2AS, or V square is equal to U square plus 2AS. What is missing in this is time. So the first one, V equal to U plus AT, S is missing. Second one, S is equal to UT plus half AT square. See, S is equal to UT plus half AT square. V is missing. Okay. And the last one, V square equal to U square plus 2AS, time is missing. So these are the three equations of motion with which we are doing all the numerical. In this, S is missing, in this, velocity is missing, and in this, time is missing. They are called as kinematic equation. That means equations which give us the relation connecting all the parameters which are involved in motion. As said in the beginning, if the motion is along one straight line, we call it as motion in a straight line or linear motion. And motion in a plane means two dimensions are coming. That means suppose if a particle is here, then we need to know how much from x-axis and how much from y-axis. Such type of a motion, we call it as plane. Like if the car is moving not on straight line, it is moving to other lane, then it is called a plane. Then kicking a football, okay, there will be x-axis and y-axis. The satellite orbiting, any object which is moving around a circle, that means circular motion, we call it as a two-dimensional motion. So what is uniform circular motion? When an object is moving in a circular path Okay, we call it a circular motion. And if it is moving with a constant speed, it is called a uniform circular motion. So what will be the velocity? What is the total distance traveled by the circular path is 2 pi r, and time taken for one full path is called time period. Okay, so velocity can be calculated as 2 pi r divided by t. And acceleration, when we learned that in circular motion, whenever an object is moving along the circumference of a circle, okay, for example, if the particle is here at A, the velocity will be in this direction, because velocity along a circular path will be always tangential. Now, when the particle reaches B, again the velocity will be tangential. It reaches C, again the velocity will be tangential. So, we have learned that whenever velocity changes, there will be acceleration. Okay, that velocity change can be either magnitude or direction. If it is uniform circular motion, magnitude will not change because it is moving with a constant speed. Magnitude, no change. But as the direction is changing, direction changes. So since the direction changes, we say that the motion is accelerated. So acceleration is non-zero if the velocity of the object changes. So the velocity changes if either the magnitude or direction change. So in a uniform circular motion, magnitude will not change, but the direction change. And how do we get the V average? 2 pi r divided by what is the total time taken is time period. So this is the total content of the chapter describing motion.